All right, welcome back to lesson 8.2.2. For some of you guys, it could be several hours or days. For me, literally a minute or so. So, let's begin. 8-8.2.2, more real and complex roots. I know how excited you guys are. I can see it. I can hear it in your voices. Yay, more complex roots. So let's get started. Based on the following graphs, how many real roots does each polynomial function have? Justify your reasoning. So for the first one, how many real roots does it have? So how many times does it cross the x-axis? Twice. 2 real roots. And how do we justify its reasoning? It crosses the x-axis twice. How about the next one? I count 1, 2, 3. 3 real roots. How do I know this? Crosses the x-axis 3 times. So, real roots are only possible if it crosses the x-axis. If it doesn't even touch the x-axis, you don't have a real root. You don't have any if the function doesn't cross or touch the x-axis. Hopefully that was understood in the last lesson. That's something I went over towards the beginning. Review that if you have any more questions. Let's do the second bit. Graphs A and B above have been vertically shifted to create graph C and D below. How many real roots does each of these new polynomial functions have? So let's look at this one, which was the second one up here. If we look at that one, we can see it has only one real root. Now let's look over here on this one. Does it ever touch the x-axis? No, so it has 0 real roots. All right, now let's solve for E. Do the polynomials in parts C and D have fewer roots than the corresponding polynomials in parts A and D? Not necessarily. They don't have to. They could, but they might also have complex roots that we can't see. So I'm going to write they could have complex roots, so no. That's what I see, right? Because we've already touched down on complex roots in the last lesson, so we know those exist and those can be counted as roots. Didn't say real roots, just asked you for any roots. So let's do 8-73. This is a long one. I'm not going to read it. I'm going to summarize it. So it's given us 3 graphs with 3 different roots, right? So let's go through them. How many roots does this one have? 1, but it's a double root. How many roots does this one have? 0, like the one up here. And how many roots does this one have? 2, right? It's intersected twice. So let's read part A. How many times can a polynomial degree 3 intersect the x-axis? Make a sketch of each possibility. So we know that what do we know about a polynomial of degree 3? It has opposite end behaviors. And because of that, we know it has to have at least 1 real root, because one of those end behaviors has to cross through them. And what are the maximum number of real roots that we know with a degree 3? How many times can it intersect the x-axis? Right, 3 times. So we can state that it can cross through the x-axis 3 different times. Cross through. It can intersect the x-axis 3, 2, and 1 time. I guess the second time isn't really intersecting the x-axis, it's touching the x-axis, but it does show that there's a real root in that area. So how can we prove that? By sketching it. Let's do 3. Right? Here's my graph. 1, 2, and 3. This is what a polynomial of degree 3 looks like. And there is my graph proving that it can be intersected 3 times. Now, how is it gonna look like if it's being intersected twice? One of those bumps is just gonna touch the x-axis, like so. 1, 2, and then there you go, 2, just 2. Because this point just touches it, although it's a very fat touch, so it could have multiple answers, but trust me, only has one. And let's do it touching it 1 time. And guess what? We already have that function right up here. So I will draw mine like this. You could draw it however way you want. And now you're saying, well, maybe there is a 0 time. Well, I mean, one of them has to cross through. Like, I could have drawn that going downwards and this going upwards. But one of them is going to cross the x-axis. It can't have it. A degree 3 polynomial will always have at least one intersection across the x-axis. Or it isn't a degree 3 polynomial. And that's what part B is talking about. Part B is talking about, can a 3rd degree polynomial have no real roots? And the answer is no. And why? Because one of the end behavior will hit the x-axis. And that's it. That's all we needed. All we need to know. So let's go on to the second page. Let me get it ready. There we go. And I'll bring out my highlighter for this one since there aren't any markings for us to write the answer except for the graph. So let's read the question. For each polynomial function below, determine all the roots and describe them completely, real or complex, and irrational or rational. Then sketch a graph of the function. Seems, yeah, simple enough. So we're going to determine all the roots first. So let's start with number 1. I know, here, I'll just read it out loud to begin with. F of x equals x plus 4 times x squared minus 2x plus 5. So we don't need to solve anything. We just need to find the real roots or complex roots of this function. So let's begin. I'm going to set it equal to 0. 0 equals x plus 4 times x squared minus 2x plus 5. And then I can also set x plus 4 equal to 0 and x squared minus 2x plus 5 equal to 0. So what's x plus 4? When we solve for x, we get x equals -4. So that's one root. And we know that to be a real root, so we'll put real. Real, and it's going to be, yeah. So let's do the second one. X squared minus 2x plus 5. Since we cannot, there's no way to solve this without using the quadratic equation or completing the square. So I am going to complete the square because it's easier. I don't want to use that function. X squared minus 2x equals -5. And I left myself room so I can complete the square. So 1/2 of 2 squared, which is plus 1, and then add 1 over here. So I'm going to get x minus 1 squared equals -4. Then I'm going to square root both sides. And you can tell where this is going already. I'm going to get, oops, I wrote 2. I had two parentheses. And then when I square root both sides, I'm going to get the absolute value of x minus 1 equals square root of negative 4. To get rid of the absolute value, x minus 1 equals plus or minus square root of negative 4. And then all I have to do is add 1 to the other side. 1 plus or minus 2i. I've already evaluated. We've done it in the last lesson. So I have, these are complex roots. So now I have one real root and two complex roots. So we already know it's a degree 3, but how many times is the function going to intersect the x-axis? Once, correct. And it's gonna, what are the end behaviors? Here, there's something else we can write down to help us sketch the function. What about the end behavior? End behavior, since it's positive, the leading coefficient is positive, and it's also degree 3, we're gonna get down, up, end behavior. I can also find the y-intercept if I really wanted to. Y equals 0 plus 4 times 0 squared plus 2 times 0 plus 5. And what do I get? Y equals 20. So y-intercept is at 0, 20. So I think we have enough information to sketch the function. I'm going to put negative 4 somewhere over here. I'll label them after I'm done sketching the function. And I forgot to, I'm going to highlight the roots that I have. Here's one, here's the other. Just so you guys know that these are my roots. We've already found them. So let's sketch the function. So I'm going to put in my y-intercept as well, 0, 20, somewhere up here, which is fine. It doesn't have to be exact, although the rest of my graph isn't going to be exact. So it starts off by going down. I'm just going to assume it hits this before it makes another curve that doesn't hit the x-axis, because my complex roots are 1 plus or minus 2i. So I know it's past, it's 1, a little bit over 1. A little over, a little under 1. So I'm going to come back down, just come back up. And that's my sketch. Let me label my points. 0, 20, and negative 4, 0. There we go. That's my first one done. So hopefully you guys will feel comfortable enough to do the second one by yourself, but I will do it right now. Pause it if you want to try it yourself. So let's get started doing the same thing. I'm going to set the function equal to 0. I'm going to have to scooch down. Sorry, you guys won't be able to see the function, but you guys have it in front of you. So we're just going to solve it. 0 equals 3x squared plus 27 times x squared minus 16. And we know we can set these two separately equal to 0. So I'm going to set 3x squared plus 27 equal to 0 and x squared minus 16 equal to 0. And then I'm just going to solve and find my real or complex roots. 3x squared equals negative 27. Divide both sides by 3. X squared equals negative 9. Square root both sides. I get x, absolute value of x, equals square root of negative 9. And then I get x equals plus or minus square root of negative 9. X equals plus or minus 3i. Right? Check my work. Make sure it's good. Make sure you have the same answer as me if you tried it beforehand. If I went too fast, I just went step by step, did PEMDAS, isolated x, solve for x. So let's do the second one. I'm going to add 16. X squared equals 16. Square root both sides. X equals, absolute value of x equals 4. X equals plus or minus 4. I didn't need to leave it in square root 16 because I know. And now that I found both of my answers, this one is real and this one's complex. I'm also going to highlight them. Done. And we can do the same thing we did with the other ones. Let's talk about the end behavior first. I know it was from the few lessons ago, 8.1.1. And in that lesson, it talks about end behavior. Should have mentioned that earlier. A little difficult doing these through the video. I'm just talking to myself most of the time. So, for the end behavior, how many degree do we have? 4, right? And what is the leading coefficient? Positive or negative? It's going to be positive. If you multiply 3x squared times x squared, it's going to leave you 3x to the 4th. So we know it's degree 4 and it's positive. So what are the end behavior? And the end behavior is up, up. And we can also solve for the y-intercept to help us get a more accurate graph. If you wanted, so y equals 3 times 0 squared plus 27 times 0 squared minus 16. What do I get? Y equals negative 432. Yeah, these are some really big numbers, but this is what happens. This is what usually, it doesn't always happen this way, but for these problems, yeah. And it's not any more difficult because we can set a new scale on the y-axis to create a much cleaner graph, which I've been doing. But it won't be this difficult on your exams or quizzes, so don't worry about that. 0, negative 432. That's my y-intercept. All right, we have enough information to graph this. Let's put on the real roots first. Negative 4 and positive 4. They're about, nope, a little bit more, and yeah, about even. And I know it's 0, negative 432, which is somewhere down here. And you'll know why I left a gap soon enough. And since both the end behaviors are up, I'm going to start up, come back down. Oh, but I can't hit it immediately. So I'm going to come back a little bit below it, come back up. I'm going to touch it because I'm going to say that this is the line of symmetry, so to speak. I don't really know this. I'm just making it up to make it nicer for me to draw. And then come back and go up through 4, 0. So now I'm going to label my points. And this point is 0, negative 432. And that's how I would sketch and graph the function. That's how I would do these two problems. And that's the end of this lesson, 8.2.2. Next time you're going to see one of these videos is going to be on chapter 9, I believe, unless we're skipping chapter 9, which I don't know yet, but we'll find out in the upcoming week. Ask me questions when we have our Zoom meetings, and yeah, I hope you've enjoyed chapter 8. Thank you.